Shri Sai Ram. Dear students, hearty welcome to one and all for the 9th class State Syllabus Science Textbook 1, and the chapter is Matter Around Us Pure. For our better understanding of this chapter, out of 3 parts, today we will be dealing with the part 2, which mainly deals with mixture. Before we pass on to the mixture, the part 3, let us recap our previous part 1's main points and also check out the assignment 1 answers for the questions that were given and get it cleared. In our previous class, we came to know that the matter which has mass and occupies space, in its physical form, it exists in solid, liquid and gas. And the chemical nature of the matter, for the better understanding, we classified it into pure substances and mixtures. Further, we also dealt with the pure substances, which are further classified into elements and compounds. We came to know same kind of atoms that are combined to form an element. And the element is denoted by symbol. Further, the element on the basis of various criteria, we classified them into various kinds, mainly on the basis of number of atoms, on the basis of physical nature, on the basis of physical and chemical properties, which we understood in our previous class. We also continued about compounds, where a compound is a combination of 2 or more elements in a definite proportion, which is called as a compound. Example, water, where we came to know only 2 atoms of hydrogen and 1 atom of oxygen only combined can give as 1 molecule of water. Here, the compound, the elements will lose their identity and a new substance is being formed. Further, we came to know the difference between elements and compounds. The short scientific notation to denote a compound is called the formula. Dear students, further, the elements classification, for our better understanding in higher classes on the basis of its physical and chemical nature, we understood that these elements are classified as metals which are shining and which have the malleability and the ductility property, a good conductors of heat and electricity. The non-metals, highly contrasting to the metals, which do not shine, which do not have the properties of malleability and ductility, and are poor conductors, or else they are insulators. Metalloids, which are the intermediate state between metals and non-metals, the arsenic, the antimony, the bismuth, the silicon, which are the examples for the metalloids. They behave both as metals and also as non-metals. Dear students, hope we recapped the main points of our previous chapter, now of our previous part, and now the assignment 1. Let us check out our answers, whether clear or not. The first question, chalk powder differs from iron. How? The chalk powder, it is a compound Iron is an element. The chalk powder is a compound. Its formula CaCO3. An element, an iron is an element. Its symbol is Fe, derived from the Latin word called ferrum. The chalk powder, since it is a compound, a new substance is formed. An iron is an element, so no new substance. The chalk powder denoted by the formula, that is CaCO3 is the formula for chalk powder. Chemical name, if I want to tell, calcium carbonate. Iron denoted by symbol since it is an element. The constituents lose their identity. Here the constituents will lose their identity. Constituents will not lose their identity in iron. So, this is the difference between the chalk powder and iron. Write 4 differences between metals and non-metals with examples. Metals, they are solids at room temperature except one metal, and that is mercury. The symbol for mercury is Hg, hydragyrum. It is liquid metal. As non-metals, they can be solids, liquids or gases at room temperature. A liquid non-metal is bromine. The symbol is Br, which is a liquid non-metal. Under the metals, they are lustrous, which means shining. Non-metals, non-lustrous. Metals have high melting and boiling point. The non-metals, low melting and boiling point. The metals are malleable and ductile. We came to know that malleability, metals beaten into sheets, MS. Ductility or ductile property, the metals drawn into wires. Whereas the non-metals, they are non-malleable and are also non-ductile. The metals, iron, the symbol is Fe. Aluminium, symbol is Al. Copper, the symbol is Cu. Sodium, the symbol is Na, are the examples. For the non-metals, oxygen, O. Hydrogen, H. Carbon, C. And nitrogen, N. They are the symbols of the elements which are non-metals. Hope the students have written perfectly the answers of the first 2 questions. Now, let us verify for the third question. Classify the following into physical and chemical change. Dear students, if we just recap our previous class, what we dealt about physical change, then easy for us to differentiate. Here we are finding the physical change, a change which is reversible, a change where no new substance is being formed. Melting of wax, the wax melts into liquid, again it can convert into solid. So, it is example for physical change. Freezing of water, the water when kept in refrigerators freezes to form ice, and that ice again when kept in hot sun, it again converts to water. So, there we can see the originality of the substance can be retained and regained also. So, we call that a physical change which is a reversible change, a change which is temporary change, a change where no new substance is formed. Only the physical form may change, that's all. The chemical nature of that substance will be one and the same. So, freezing of water is an example for physical change. Chemical change, growth of a plant is a chemical change. A change which is irreversible, a change where new substance is formed, a permanent change. So, growth of a plant is a chemical change. Digestion of food. Once the food gets digested, again if you want to get back the food that you have eaten in the same form what you have taken the food, you can't. So, it is a chemical change. Burning of a candle, the wick of a candle that is burnt will not get back the wick again after it is been burnt. So, it is a chemical change. Rusting of iron, iron which is a hard metal, due to moisture and air, it becomes rusted. The rusted iron becomes very smooth, easy to break. So, the original iron is very strong. We can't get back the original iron when the iron gets rusted. So, the originality cannot be regained. We call that as a chemical change. So, hope all the students have written the physical change and chemical change examples by classifying them to which change they belong to. Dear students, and today we move on to the part 2 of this chapter after the recap and clarifying our assignment 1 answers for the questions that was given. Hope that all of you have corrected it, and let us move on to mixture. What a mixture is? A mixture is a combination of 2 or more substances in any proportion. In any proportion, the combination of part 2, mixture. A mixture is a combination of 2 or more substances in any proportion. Example, air, milk, petrol, brain, paint, glass, etc. They are all the mixture examples. Dear students, before we go to the types of mixtures, let us have a simple look at the setup that is being made. I have taken 200 ml 3 borosilicate glass beakers, and each beaker I have taken water. Then one of the substance in a watch glass is salt, the common name, but the chemical name is sodium chloride. And this is the spatula that is used in the labs for adding the substances. In another watch glass, I have taken soluble starch powder. And another watch glass, all of you observe, it is sand, that is silicon dioxide. Now, a very simple experiment. I am going to add some amount of salt into the first beaker, which I have taken water, and I am going to stir it. Hope all of you are observing. So, on stirring, the salt that is added to the first beaker, which is containing water, we can observe that the salt is totally dissolved. Very good. You all are answering from there. So, here you can observe that a beaker of water with its salt, some amount of salt that is added, has totally dissolved. So, it forms one sort of solution. We call this as solution. And now, to the second beaker, I have taken in a watch glass soluble starch. The word soluble is very important, which is soluble in water. Now, I am going to add the starch. You all are observing a difference. When I added salt to the same water, it was not having that much of brightness. But here you are observing. Now, I am going to stir it. So, here you have observed which solution? It is starch solution. It is starch solution. The third beaker, I am taking sand. Now, I am going to add some amount of sand into this beaker. And let us stir it, how we have done there. Dear students, in all these three beakers, I have taken water. For the first beaker, we added sodium chloride salt, some amount, in such a way that it is totally soluble in that water, totally dissolved. Where is it possible for us to identify where the salt is? Not at all. So, this is one. And this is the starch solution we tell. Can we tell that the starch is there? Sure. But it is not possible to remove the starch from this water. And here it is, you can see the layers also, two different layers are there. Sand, which is not soluble in this water, it is insoluble in the water. The mixture chapter reminds me of these three types of mixtures. This is solution, this is colloid, and this is suspension. Dear students, let us understand in detail about the solution, about the colloid, and also about the suspension. As we observed, a simple experiment of three different substances put in three different beakers containing the water, where one of the substance totally dissolved, the other substance is dissolved, but we come to know that what substance is being put in that. And the last one, it is not at all soluble in the water. We can find the layers, the sand and the water layer we can observe. Whereas the soluble starch that is put, we come to know that starch is put, but we can't tell the differentiation of the layers. Whereas in the first one, where the salt was dissolved in that water, a salt solution, we can't tell that it is salt solution unless we taste it. These are different kinds of mixtures. To the 9th standard level, which we will be studying further. Now let us concentrate here. As I told you on, 2 or more substances in any proportion when combined, it is called as a mixture. And the types of mixtures: homogeneous mixture, heterogeneous mixture. Homogeneous mixture, a mixture of 2 or more pure substances forming single phase. The salt solution which you observed, salt and water, but it is in single phase. It is homogeneous. Have uniform composition throughout. Throughout that solution what we have taken, which is having salt and water, we can't identify where the salt and where the water is. Throughout, we have a uniform composition in a homogeneous mixture. Example, sugar solution, air, alloys. What is this alloy? Alloys is plural, alloy, a combination of 2 or more metals or a metal with a non-metal is called as an alloy. Even though there is a combination of metals together or a metal and a non-metal is combined, still we don't see different layers. It appears as a single phase. Brass, bronze are the examples for alloys. Heterogeneous mixture, a mixture of 2 or more pure substances forming many phases. We observed sand and water. When combined, we can see layers, phases are being visible. They do not have uniform composition throughout. Here solid with solid, salt and sugar when combined, you can easily observe. A chalk powder or chalk and water, it is heterogeneous. More examples, oil put in water, heterogeneous. Oil is not dissolved in the water. Oil floats, we can see the layers, different phases are observed. So it is heterogeneous mixture. So mixtures for our understanding is of homogeneous and heterogeneous mixtures. Properties of mixtures. The constituents in a mixture are separated by physical process. Since it is a mixture and in any proportion, by any physical methods we can separate them. The constituents are in any proportion, do not have definite melting and boiling point for the mixtures, usually are heterogeneous. So, usually most of them are heterogeneous in nature. Now, the 3 simple experiments which we have observed, among them the first one, solution. What this solution is? A solution is a homogeneous mixture of 2 or more substances. It is a liquid formed by dissolving a solute in a solvent. Dear students, observe the words. A solution is formed by dissolving a solute in a solvent. Sugar solution or salt solution was an example. Solute, a component present in smaller quantity. It may be sugar or salt. Solvent, it is a component that is present in larger quantity. The example is water. So, solution, in very simple way, you can remember what a solution is. A solution is a solute plus solvent. Sugar solution is an example. Then which is the solute? It is sugar, where we have taken in very less quantity. Which is the solvent? Water is the solvent. We have taken more quantity. We observed the first beaker, water and also the salt that we dissolved in it. Properties of a solution. It is a homogeneous mixture. A single phase is observed there. The particles cannot be seen by naked eye. The path of light is not visible. The solution will be stable since the solute cannot be separated from it. It is a stable one because the solute is totally merged with the solvent in that. So, it is very stable. These are the properties of a solution. Solubility. The amount of solute present in the saturated solution at a given temperature is called its solubility. What do you mean by this saturated solution? A solution in which no more solute is being dissolved in the given solvent, then it is called saturated solution. Dear students, you have sugar solution. 100 ml beaker, you have taken about 100 ml of water. To that you add 2 to 3 spoons of sugar. Then it is soluble. You go on adding to that more than 10 kgs of sugar. Will it be soluble in that water? Even though sugar is soluble in water, but if the solute is more than the solvent, then the solute will not dissolve in that solvent. So, we call that stage the solution as saturated solution only when no more solute is soluble in the solvent. Then we call it as the saturated solution. So, the amount of solute that is present in the saturated solution at a given temperature is called its solubility. The concentration of a solution, it is nothing but the amount of solute that is dissolved in given mass or the volume of solvent. A simple equation, the concentration of solution is equal to amount of solute divided by amount of solvent. It is the concentration of solution. The concentration of solution by percent by mass is nothing but the mass of solute by mass of solution into 100. The second part, percent by volume of the concentration of solution is the mass of solute by volume of solution into 100. Let us work one example here. A solution contains 40 grams of common salt in 320 grams of water. Calculate the concentration in terms of percentage by mass of the solution. Dear students, read the question twice so that you will understand what is the data given. A solution contains 40 grams of common salt. So, let us write common salt. What is the formula for common salt? Very good. It is NaCl, sodium chloride. So, how many grams? It is 40 grams. Is added to what? Water. Water, how many grams is taken? So, water is 320 grams. So, sodium chloride will be what? Solute. It is very less in quantity, whereas water is more. So, it is solvent. And they told a solution is formed. So, solution is nothing but solution is equal to solute plus solvent, which is equal to solute is 40 grams plus solvent is 320 grams, which is equal to 360 grams of solution. Which solution it is? Salt solution. So, this is 360 grams. So, what is the formula for percentage by mass? They have asked you percentage by mass is equal to mass of solute divided by mass of solution. Since it is percentage, multiplied by 100. So, here you are going to get mass of solute, that is 40 grams, divided by mass of solution, it is 360 grams, into 100. So, a simple mathematics where the numerator 0 and the denominator 0 get cancelled. Multiples of 4, 4 ones are, 4 nines are 36, which is nothing but, again we see here 100 in the numerator divided by 9, simple division 11.111 where 1 is recurring, so we put above 1, that much percentage. Though the percentage by mass of the solution is 1.1%, which is recurring. I hope all of you understood the simple mathematical problem where you should know solution is equal to solute plus solvent, the formula. Next is they have asked you to find percentage by mass. So, percentage by mass will always be equal to the mass of the solute divided by the mass of the solution into 100, since they have asked us to find the percentage. I hope all of you have understood. Now, let us see worked example 2. 5 ml HCl dissolved in 100 ml of water. Calculate the concentration in terms of percentage by volume of the solution. Here both are in liquid state. The concentrated HCl is being dissolved in 100 ml of water. Here a slight change you have to make in the problem is dissolved to get 100 ml of dilute HCl, it should be. Try to correct it. To err is human, to forgive is divine. No man is perfect. So, errors come, let us correct. So, the problem you correct it, 5 ml of HCl dissolved to get 100 ml of dilute HCl. Calculate the concentration in terms of percentage by volume. Now, let us see what is the solute. Given data, solute is nothing but the HCl, which is 5 ml. No need of solvent here. because it is dissolved to get how much? 100 ml of dilute HCl. That means 95 ml of water it is dissolved. So, let us take the solution, the dilute solution, dilute HCl. How much ml? 100 ml. So, what they have asked you to find the percentage by volume, which is always equal to the mass of solute divided by volume of solution into 100, which is equal to the mass of solute 5 divided by 100 into 100, because the dilute solution is 100. So, numerator 100, denominator 100 get cancelled. So, percentage by volume of the dilute HCl is 5%. It is very simple calculation, which by practice it will make you perfect. When any sort of mathematical problems, if it is given, dear students, read the question twice, write the data what is given, which formula is used, then start substituting the values. Never give up, never give up. Try and you will succeed. So, I hope you all have understood this problem. Now, the second part, to the solution, we came to know that the solute is totally dissolved in the solvent. And now we come to the suspension. What this suspension is? It is a heterogeneous mixture. The solute particles remain suspended throughout the bulk of the medium, where the solute will not dissolve in that solvent. It will remain as it is. So, we can see different phases. Example, muddy water, the third beaker which you observed in the beginning. Chalk dissolved in water, they are all examples for suspension. The properties, it is a heterogeneous mixture. The particles are seen by naked eye. They scatter a beam of light. It is highly unstable, where you can observe here, dear students, can observe here the muddy water, the sand is put in the water, it is not been totally dissolved, it is suspended throughout. Even if you stir it, it is highly unstable, can scatter the beam of light because the particles are observed. We can see from the naked eye the particles of sand. So, this sand solution or muddy water is an example for suspension. Next, we move on to the colloids. See, colloids, they are the intermediate state between a true solution and a suspension. A true solution means a homogeneous solution. You saw there, the first beaker had the salt dissolved in water. The second beaker had the starch, soluble starch in the water. And the third beaker had sand and water. So, the middle beaker is a colloid. It's an intermediate state between a true solution and a suspension. Example, smoke, milk, honey, butter, table jelly, etc. They are the examples for colloids. The properties of these colloids. Colloid is a heterogeneous mixture. Surely, when we observe, for your kind, if you observe this, a soluble starch, so I have added some soluble starch and I am dissolving it. We can easily tell that the starch is there, but we can't remove it. So, we tell that it is a heterogeneous mixture as well as behaves as a homogeneous mixture. That is why we tell an intermediate state between a true solution and suspension is this colloid, a starch solution. That too, which starch? Soluble starch. It is, in here you can observe small amount of the water of the cooked rice. Another ganji in Kannada we call. It is also a starch. It is a colloid. The water of this rice that is being washed or while cooking, another ganji we call. It is an example for colloid. The size of particles are too small, which are invisible. Surely, it was not possible to see the starch particles. They scatter the beam of light that is passing through it. A unique property of colloids, Tyndall effect, found by Tyndall. So, it is called Tyndall effect. What is Tyndall effect? Scattering of light is called Tyndall effect. It is been by the colloids. The particles do not settle down when left undisturbed. It means they are quite stable. Colloidal solution contains two phases. Very important here, everyone should note. The dispersed phase in the colloid is called as the solute. So, I added soluble starch, that is dispersed phase. Dispersed medium, it is solvent. To that water, I added soluble starch. So, soluble starch was the dispersed phase and the water was the dispersed medium. So, the colloidal solution has two phases, the dispersed phase, which is nothing but in general terms called as solute, and the dispersion medium, which is nothing but generally we call it as solvent. Types of colloids. Dear students, the types of colloids on the basis of physical state of dispersed phase and dispersion medium, to our understanding of the 9th level, we have 8 types. So, the 8 types are, let us see first the dispersed phase. So, dispersed phase is solute part, very less in quantity. Dispersing medium, it is solvent part, and the type, then the example. So, liquid is the dispersed phase and the dispersing medium, if it is gas, it is aerosol, the fog, the clouds and the mist. Liquid, gas, aerosol. Very important from the exam point of view also. In clouds, which is the dispersing medium. We should write gas. In clouds, which is the dispersed phase? It is liquid. Dispersed phase is solid and the dispersing medium is gas. Again it is aerosol, but here the dispersed phase, if it is solid, then the example is smoke. Cigarette is a solid, but the smoke that is left out after burning that cigarette, we see that smoke is an example for the aerosol, where the dispersed phase is solid and the dispersing medium is gas. The automobile exhaust also. The third type, gas is the dispersed phase and liquid is the dispersed medium. Foam, shaving cream is an example for that. See the shaving cream, it is an example. The fourth type, liquid is the dispersed phase and dispersing medium is also liquid. Emulsion, milk and face cream, what all we use, cosmetics, they are all examples for the emulsion type, which is having the dispersing medium as liquid and the dispersed phase is also liquid. The fifth one, solid is the dispersed phase and liquid is the dispersing medium. Sol is the type, milk of magnesia and mud or the soil. Gas is the dispersed phase, solid is the dispersing medium. Foam, rubber, sponge, pumic, they are the examples. Liquid, the dispersed phase, solid, the dispersed medium. The type is the gel, jelly, cheese, ginnu, we call it as butter, benne. They are all examples for gel type, where the dispersed medium is solid and the dispersed phase is liquid. Dispersed phase is solid, the dispersing medium is solid, both are solids. Solid sol, colored gemstones, the rings what we use, the stones, milky glass, they are all examples for the solid sol, where both the dispersing medium and the dispersed phase are solids. Dear students, by seeing the examples, you should understand which is the dispersing medium and which is the dispersed phase. Finally, the type will be known. By practice, you can become perfect to know the types of colloids on the basis of the dispersed phase and the dispersed medium. Uses of colloids. So, where all these colloids are used. By knowing the examples and the types, we come to know in many pharmaceutical preparations, these colloids are used. The colloidal silver, such as argyrol and protorgol, are used in eye lotions. The colloidal arsenic is used in the treatment of eye disease. The colloidal calcium and gold are also being used. The colloidal sulfur used as an important insecticide. These are the uses of colloids. More, in food, the milk casein are used as protective colloid. Gelatin, the gelatin is added to ice cream to preserve the smoothness and fine texture. In industries, The colloids have many uses such as in cleaning water, the sewage disposal, rubber plating to control the smoke precipitators, chrome tanning and in building roads. A comparative study of a true solution, colloid and suspension. Dear students, a very important from the exam point of view also. What is the property? Suspension, colloidal solution and solution. Why? Colloid is an intermediate between a solution and a suspension. If you observe the particle size, in suspension it is greater than 100 nanometers. In colloidal it is from 1 to 100 nanometers. In solution it is less than 100 nanometers. Filtration separation. It is easily filtered, the suspension. Not possible in colloid to separate the solute, but in solution also not possible to separate. Settling of particles, the settling on their own, whereas here settling on centrifugation. The particles do not settle in solution. Appearance, opaque, transparent and also transparent in solution. Tyndall effect, it shows to some extent. Colloidal solution also shows the Tyndall effect. So, what is Tyndall effect is? Scattering of beam of light is called Tyndall effect, whereas the solution does not show the Tyndall effect. Diffusion of particles, the particles do not diffuse in suspension. They diffuse slowly in colloidal solution. The diffusion is very rapid in solution. Brownian movement, zigzag movement of particles is called Brownian movement. May show to some extent on stirring, that's all. Whereas the colloidal solution shows a beautiful Brownian movement of particles. The zigzag movement of colloid particles is called Brownian movement. It is seen in colloidal solution, whereas in solution may or may not show the Brownian movement. What is the nature? It is a heterogeneous mixture, the suspension. Even the colloidal solution is a heterogeneous mixture, whereas a solution is a homogeneous mixture. A true comparative study of true solution, colloid and suspension. Tyndall effect. If you observe the picture, dear students, a unique property shown by colloids only. See, a solution, no Tyndall effect. A light, a flashlight is being made to pass on the three solutions: solution, colloid and suspension. Here we see more. Here we see, but not much in the suspension. So, this is Tyndall effect is observed. When a beam of light is passed through solution, no Tyndall effect, no scattering of light. But the light is scattered in the colloidal solution. In suspension, some amount of light is being scattered. So, this is about the Tyndall effect. Dear students, the comparative study of a true solution, a colloid and a suspension. In the true solution, we are seeing a single phase homogeneous, whereas a colloid heterogeneous and a suspension heterogeneous. The filtration is highly impossible. The filtration is also not possible, whereas the particles can be filtered in this suspension. A transparent, but this is an opaque. These are some of the comparative study of a solution, that to a true solution, a colloid and a suspension. The unique properties are the Tyndall effect, where we see the Tyndall effect when a beam of light is passed through a solution, a colloid and a suspension. We can see the beam of light very bright in a colloid, less bright in a suspension, and no Tyndall effect in solution. So, what is Tyndall effect? Scattering of beam of light through the colloid particles. This is called as the Tyndall effect. Why there is more scattering in the colloid particles? Here in the colloid particles there is more scattering because they are charged. The particles are charged. They are neither settled nor they are totally merged with that water. They are being charged and moving. So, the charges of the colloid particles will make the beam of light to get scattered. The next one, the Brownian movement. A unique movement. You can observe the picture here where we have taken 2 bottles containing the water and 2 to 3 drops of ink if you are going to put. You can do it practically by yourselves. The ink particles starts to move slowly by themselves. They slowly start to spread throughout the water. You can observe that. So, the colloid particles have this Brownian movement, the zigzag movement of colloid particles, which is called as the Brownian movement. The most unique properties of these colloids, which we understood, the first one, which was the Tyndall effect, the scattering of beam of light by the colloid particles since the particles were highly charged. The second property, the Brownian movement, the zigzag movement of the colloid particles is called as the Brownian movement. The picture which you will observe, in 2 bottles of water, we added 2 to 3 drops of ink and you can see the spread of ink by itself without any efforts. This is the zigzag movement of colloid particles. The third property, coagulation. What this coagulation is? Settling down of the charged particles is called as coagulation. If you observe the picture, see the impurities, the particles are moving in all the directions. The coagulate, dear students, you might have observed in saloon shops, the potash alum to tell you all. So, the potash alum, Al2SO4, twice 24H2O, aluminum sulfate. So, potash alum, this alum is a very good coagulant. It clots, coagulates, settles down the charged particles. So, settling down of the charged particles is called as coagulation. When you add a coagulant forms, the trapping the impurities and all the impurities starts to settle down. Settling down of charged particles is called coagulation. The potash alum is a common example for this. Assignment 2. Dear students, today's class of Is Matter Around Us Pure? The second part mainly about mixture, where we understood homogeneous and heterogeneous mixture. Further, we continued to some extent about solution, suspension and colloid. And finally, we had a comparative study between a true solution, a suspension and a colloid. Unique properties of colloids, the Tyndall Effect, the Brownian Movement and the Coagulation. Hope all of you have understood that today's part 2 of the chapter is Matter Around Us Pure. Just to test ourselves and to recap, here you have it, the assignment 2. Classify each of the following as a homogeneous or heterogeneous mixture: soda water, wood, air, soil, vinegar, filtered tea. You should classify them into homogeneous and heterogeneous mixture. Second question, compare the properties of a true solution, colloid and suspension. So, you should write the comparative study of all the three. Hope. The third question, give reasons for the following. Brass is, dear students, technology is technology. To err is human, no man is perfect. The question is slightly wrong, never mistake. Write down, the first one is brass is an alloy. Brass is an alloy. Second one, potash alum is used to separate suspended particles in water. Third one, when light is passed through colloids, the path of light is seen. Why? The fourth question, to make saturated solution, 36 grams of sodium chloride is dissolved in 100 grams of water at 293 Kelvin. Find its concentration at this temperature. The students, a simple mathematical problem. I hope all of you will surely put efforts and work out honestly. The part 2 of Is Matter Around Us Pure, which mainly dealt with mixture. We shall offer everything at the feet of the Almighty. I hope all of you have understood, and also I believe everyone will be ready for the next coming of the same chapter, last part, that is part 3. Till then, have a good time. Thanking you one and all. Jai Sai Ram.